Ja, und damit nähern wir uns schon langsam dem Schluss. Wir haben noch eine Keynote für Sie übrig und das freut mich außerordentlich, dass wir nochmals ein bisschen den engen technischen Fokus verlassen und vielleicht auf ein Thema kommen, das nicht so direkt mit IoT zu tun hat oder doch mehr. Es ist das Thema Spatial Computing and the Industrial Metaverse, haben wir schon gestreift und dazu darf ich Marc Pollefeys begrüßen auf der Bühne. Er ist Professor Computer Science ETH Zurich und Director Microsoft Mixed Reality and AI Lab. Welcome on stage, Marc.
Thank you. So indeed, I won't directly talk about IoT, but IoT is essentially about measuring things in the real world. It's part of the broader digitalization, the digital transformation of having more and more of what's happening in the production process, in a factory, etc., having a digital footprint of that, a digital record of that. So what I'll talk about here, and you see it illustrated on this picture, is bringing people that are on site fully into that digital world also, giving them a natural and intuitive access to that digital information. Because this information is in a spatial context, it's important to be able to keep track of that. It can mean giving access to IoT data, for example, as you see illustrated here on this slide. But of course also many other data sources, explanations about how machine works, tutorials, etc. It can be assistance from an expert that's not on site. It can also be about actually recording, as we've also heard before, with the help of robots, also helping record what the person is doing, the different steps that they are taking in a maintenance or in other places. So it's really bring the human, as we bring machines into the digital world with IoT by connecting them, doing very much enabling to do the same thing for humans, for workers, frontline workers that are in the field, in the factory, bringing them fully also in this digital world and giving them access to it. So here's an illustration of what can already be done today, what is deployed today with these type of devices like the HoloLens, letting people connect to a remote expert, also in terms of sustainability, meaning that you don't need to fly the expert or bring the expert on site, but you can actually leverage a remote expert and work with the person that you already have on site. In this case, for maintenance of cars, in this particular case, for Mercedes-Benz in the US. Another application of this type of technology is for actually teaching people. So the previous one was a complicated setup where you would need to bring in an expert. This one is more about a standard procedure that every new employee in the factory has to learn. They also, instead of having to have a person, an expert, spend a lot of time with new employees, you can actually, for the simple steps, you can actually automate that and provide a very intuitive explanation through this mixed reality by essentially providing the instructions in a spatial context directly overlaid on top of the machines that are to be manipulated. We're still at the beginning of a lot of this, so those applications are existing applications actually, but in many ways they are still limited. And if we look, we can actually bring, there's a lot of potential for bringing AI capabilities in this, and here just some research that we are doing in this direction, going from a video stream, interpreting what the person is doing, recognizing the actions, the objects that are being manipulated, how the person is manipulating the object. On the right side of the slide, you see essentially how the computer can make a digital interpretation of what is going on in the world and recognize the actions. What can you do with that? Well, here's an example of how you could apply that in a scenario, in this case, a simple task of replacing a printer cartridge. And so imagine wearing this device here, and you get essentially, you have learned how to do the step-by-step instructions, and essentially now, as you replace, it can actually follow along and digitize the different steps you are doing, how much time you spend on those steps, etc. It can also, as you'll see in this example, if you actually are confused, you've just learned how to do a task, but you're still not fully confident, it can actually detect that you did something out of order and help you correct that step, and so also help in quality assurance and things like this. So those are some applications. You can use computer vision and AI capabilities, machine learning, to help build applications, richer applications on top of a device like the HoloLens. But if you actually look under the hood, we already, in the device, have a lot of this technology built in just to actually provide the mixed reality experience. For starters, there's 4 cameras built in here, plus an inertial measurement sensor, because we don't want to place information that moves with the screens here, that would naturally move with this. We actually want to place information in the context of the world, meaning that if I move my head this way, on the screen, I need to have the graphics move exactly the opposite way so that it looks like it is standing still in the world. So we need to continuously actually measure how the device moves through the world, and we use these 4 cameras plus an inertial measurement unit very much in the same way that we use our eyes, or 2 eyes, and our inner ear system to feel motion and essentially use similar methods here. Besides that, we also have a depth camera built in. The depth camera is essentially a camera that in up to a few meters can measure for every direction, every pixel, can measure how far the scene is in that particular direction. And so the image you see here is essentially encoding how far something is based on color here. So this can be used for 2 things. One is to build a 3D model of the environment. Now, we're talking about augmented reality, so we see the environment. Why do we need to build a 3D model of the environment? Well, it's because if we want to have objects interact, the virtual objects, the virtual elements somehow be placed on real objects, not conflict with them, we actually need to know, the computer needs to know where the real world is. As a byproduct of this, it means that you actually are collecting enough data to, in the background, build up essentially a digital twin of your facility just by walking around with this device. Build, for example, floor plans or so, as a byproduct. The camera is also used in a different mode, much faster, with a shorter range, to track hands. And this is used then to enable simple and intuitive manipulation of holograms in the same way that people would actually grab real objects. They can now grab the virtual objects or manipulate digital buttons or a digital keyboard, as you see in this example here. Besides that, the device also has cameras that look at the eyes. This allows to track the eyes and do simple things like, for example, reading a text and having auto-scrolling while you're reading the text. But at least as important is actually being able to authenticate you, and this data actually stays purely on the device, so it's not networked, but actually guarantee that you are the person that has that can access. So it's biometric authentication, like on your phone, it looks at your face and recognizes you. Here, the device looks at your irises and recognizes you. But then, probably most importantly, it actually also really calibrates where your eyes are. It measures where your eyes are, because this is needed to render the right images to your eyes. Because people have eyes at different distances. If we don't take this into account, the world will look a little bit off. All the holograms will look a bit too big or a bit too small. They are a bit further out than we feel or a bit closer. This actually ruins the experience. It means that if I press a digital button, I see it here, but the computer thinks it's over there. When I press here, nothing is happening, and I get frustrated. So it's actually really important to do all those things in the background, under the hood of the device. So to do all of this in real time, it was actually needed to build in an ASIC chip here, so a custom chip that actually does all of this real-time computer vision and AI all the time for several hours on a small battery. It's a full computer, so in the back there's also, back here there's actually also a normal, essentially similar processor to one you would find in your phone. And so that actually runs Windows in this case. Of course, the device is limited. It cannot do everything. So if you connect it to the cloud, you can do more things. As in this example, you can actually use, we actually already, even for the device itself, we have to hide some of the latency because if it takes more than 10 milliseconds from sensing to rendering back to the display, and so the graphics processor needs some time to render images and so on, and if it takes more than 10 milliseconds end-to-end latency, we see that the world is a little bit behind somehow. The holograms are not fixed to the world, but they're always a little bit behind. So to compensate that, there's actually hardware that will do, based on IMU signals, a last-minute shift, last millisecond shift to correct hide the latency. This is actually also used so that you can actually now also render in the cloud and render very complex models on very big GPUs in the cloud, up to billions of polygons, and essentially do that seamlessly over Azure Remote Rendering. Then there's also the possibility to have people work together, share common digital content in a spatial context, as you see illustrated here. But then something that we are very much focused on is actually being able to share spatial information, share and persist spatial information in an actual physical context. For example, as illustrated here in construction. So as we had heard before also from Paul that gave actually a great presentation earlier today, also here in construction, you align essentially the digital twin, the BIM model, to the actual physical space, and then people can compare the plan to the current execution and course correct if needed, or see, follow along if things are built properly. So to enable all of this, what we are doing under the hood is actually, as I mentioned earlier, this device needs to continuously keep track of its position. For doing that, it actually builds a little map of its direct surroundings, just to operate. Normally that map, if I walk around this part of the building, this map will be stored on the device. Conceptually, what we're doing is we're moving that over to the cloud. Then as multiple people work with the same or with different devices, we can gradually move all of these small pieces of maps to the cloud, and in the cloud, we essentially have a cloud service that puzzles all of this back together into a map that now covers the whole environment, also a map that can stay up to date because there's always new mapping data coming in. So here's then an illustration of this on an actual real example. We actually went with a few people to an EMI factory. So this is a factory of 100 by 200 meters or so. For a few hours, walked around with these devices, did nothing else. For the map that you see on the bottom left, this allows us to then place, for example, IoT information, instructions, or other things, attach them to their spatial context. What you see on the right is then if you need a higher quality, let me play this again. What you see on the right is if you need a higher quality representation, you can actually take much more expensive devices that will do a full laser color capture of the environment, 3D capture, or technology actually allows to automatically align this. Why is this useful? It means that you can have the remote person have access to this reality capture, this essentially visual digital twin of the factory, while the person on site, of course, can be in context and both people can communicate. So with the map that I showed that we built up with HoloLens, what we can do is essentially something like this here. This is actually in our own offices in Zurich. We have this digital model. The person walks around and essentially has the digital model that was extracted from the data essentially exactly aligned to the real world, to the real physical world. And of course, what you also see is that what the person sees, this can also be represented in the digital twin, and so you know where the person is in the digital twin. And for example, if something happens, you know where the person is, you can navigate them to where some maintenance is needed or something like this. Here you also see how, in this case, the IoT related to the printer could be placed by one person, then be accessed by everyone in the office afterwards. Also, we've heard also that there's lots of things, so you can map with many different devices. You see illustrated here. This was there should have been a video here. Let's see. Okay, maybe not. You see the map on the left. This was also obtained by walking around with HoloLens. This is actually the new Microsoft Office at the Circle before it was finished. We captured with HoloLenses, but actually also with this Spot robot, as well as with a Leica scanning device. All of those can be merged into a single consistent map, which you see from the top here. You can actually also then merge in additional information and get these kind of dense models out of this. Some of the application in construction, or more in general, is actually that you can both combine what people do and give them a spatial context and give them access to all the spatial information, but also enable them to naturally work together with robots. So we've heard earlier that robots also are essentially IoT devices on wheels. The question was, do they replace people? Do they work with people? This type of technology really allows people and robots to really work together in the same spatial context, have the robot, essentially the path of the robot, be shown to the human so that the human knows what the robot will do, which can make it much easier for people to collaborate together. Then what you see in this, so what you could see in this video here is essentially an illustration of, will be an illustration of, you can also, when you're on site, you can, with the device, digitally kind of see what the robot is going to do or plan a mission for the robot. You can also do that remotely in a map. All of this based off the same cloud map, visual cloud map of the environment. The points you see here are not a detailed, full three-dimensional representation of the whole surface. It actually picks up visual landmarks, so that's why you see a sparse set of points there. And so in this case, Spot, so this robot-looking dog, can fully autonomously wake up and start an inspection round based on someone defining a mission on this map here, in this case, as an example, using exactly the same technology that we use for placing holograms for HoloLens in a spatial context. Then looking a little bit further, this is actually work at ETH, or actually work from one of my ETH students done during an internship at, in this case, actually Google. So what you see here is how essentially these large-scale AI models that are, a lot of people talk about, these large language models, which in this case are then combined with language and image representations, are learned together. And this particular paper then looked at expanding the language to image to three-dimensional model relationship, so that now you can actually do open vocabulary queries. So you don't have to learn in advance the questions the people will ask. You don't have to say, I will classify this scene in these 5 different classes, like floor and walls and this and that. We essentially have a way here to just ask open questions, like where can I sit? Or, are there decorations in this room? Or what is soft here? Or where should I cook? All of those questions can be answered from this here, as an example, from that 3D model fully automatically with these large language models in the background, just to give you some ideas of where some of this technology is going. Okay, so in conclusion, with these mixed reality headsets, users get a lot more context, task context is available to assist the user. This is both by observing the user actions through the sensors that are built in, understanding the environment also through those sensors, at the same time having, of course, being connected and having access to the relevant digital information and being able to bring that to the user, have these natural user interfaces where you can grab digital information, you can talk naturally to the device, etc., having eye tracking, and then being able to place pixels not on a display and then still requiring the user to think through and look at the display, interpret that, and apply that to the scene itself, but actually have information directly displayed in its spatial context. Okay? And what's really interesting is the combination here between what can be done on the edge, low latency operations, kind of direct interactions and so on, and then leveraging the cloud for a number of operations. Interesting aspect of telepresence, allowing people to do something in an environment, either through communication with a person that's on site, or actually also enabling access to remote places through potentially robotics. And then, of course, the synergies here between these HMDs that bring people in the digital world, robotics, ambient sensors, and IoT. And of course, while we look at all of this, a very important aspect is actually to think through privacy as of course many things are being sensed all the time, and so it's something we always pay attention to. Okay, and I'll leave it at that.
Thank you very much. So at the moment it's people wearing these HoloLenses. Before we saw robots navigating through space. Is there something in common that is usable also for that setting with the robots?
Absolutely. So essentially, this device knows where it is thanks to these 4 cameras plus an inertial sensor. This is actually the same if on your phone you play an augmented reality game. It will actually also use one of the cameras plus this inertial sensor. And robots very much use the same thing. So robots also have camera sensors, have depth cameras, have inertial measurement units. Essentially, all of those devices do so-called SLAM, the simultaneous localization and mapping. So they try to localize themselves within a map that they're still building up as they go. So that's why simultaneously you localize, but you also keep extending your map that you use, and you keep track of your relative position within the world. Almost all of them use the technique known as visual inertial odometry. So it means both visual and inertial. The combination of both is very powerful, and they actually all use them. It goes from drones to robots to these type of devices here. So it's all the same, and therefore we can easily combine and bring all of those together in the same maps, essentially.
So that goes also in the direction of one question, that we don't see these glasses very often. So is it more that their application will be for robots? Is that your estimation?
No, so I think today, this is still a relatively sizable device. So today it's a tool. It's a tool that you will use for a particular task. It's not yet a device that you would wear all day. It's a commercial device, so it's a device that's to be used in industry or for specific tasks. It's not something you would use at home, so there's currently specific high-value niche cases for maintenance, for certain set of tasks. I think we're in a few years it will come that it will be much more common. The devices will be smaller, will be all-day use, etc. For now, it's more, you have a high-value task where you can really use the help. That's when you would use a device like this, or for training also.
There was a small critique hidden in that we talk about these use cases since quite a long time, but I guess also the person writing that didn't have the impression it's already very well spread in the industry. So what is the status? Do you see industry picking up on that, or still very slow adoption?
So there are specific reasons where the pickup has been slower than expected. I think because this is technology that really changes the way people work. So for example, these remote assistants, I was hearing from actually a Swiss company, I think it was Agathon, where during the pandemic, they make high-value machines that they sell all over the world. During the pandemic, suddenly they couldn't send their technicians anymore abroad, and they had to do maintenance and so on. They could actually send the HoloLens plus all the necessary materials to do the maintenance, ship that to wherever the machine was in the world, and then essentially have a local technician work with a technician from Agathon in Switzerland work with a local technician on site and solve that problem. Now they had to do it because of the pandemic, but it changes completely what you do. Instead of having a technician to put him on a plane and send him somewhere, you now have a technician that sits at home that essentially works with someone locally there. So essentially, the business processes or the way that this is deployed changes completely the way people work, and so that actually takes time. And really, it's not something you kind of buy the device and tomorrow you deploy it. So you really have to go through a number of like there's challenges for deploying this. Also, I will admit that both at Microsoft and also at other places, this technology was initially thought through as a technology that was for consumers, and only relatively late realized that this was actually something that was much more suited for industry. The result of that is that people have a lot of things that are table stakes in industry were initially not thought through and so on, and so are only now coming about. And so that's where this has taken longer, because there wasn't enough attention paid to the full solution. And you come with a device, this is a computer essentially, but if you come with a computer without the solutions, the full solution thought through, you cannot really deploy it. It's great. So it has had a ton of success in every innovation department all over the world. Any sizable company that has an innovation department, bought HoloLenses and showed all kinds of crazy futuristic things, proof of concepts. And those essentially represent a lot of super valuable use cases. The problem was that from there to actual deployments, there was still too much friction left because not all the homework has been done and so on. So now we're essentially getting through that, but that's the reason why actually those things have gone slower than would have been expected.
I also had the impression it was very famous in workshops to show what digital transformation means, but then it somehow stopped there. So one person described it in a very interesting way. I would like to read that opinion. So the industrial metaverse is not walking around in a separate virtual world with my own avatar interacting with others, but more about augmented reality based on BIM models, digital twins, and similar. So that's basically what you just described.
Yeah, exactly.
So we leave the consumer thing. It's good for maybe gaming, or someone watches TV on the top of a mountain, but the use is in industry that you.
So I think the use is much more in industry. The reason being that if you look at, for consumers, there are price point, comfort, and other things that make it still much further out. This is something that if this really helps me solve a task, I'll be happy to put this on, spend 2 hours with this device and do that. But putting VR glasses on at home or so and isolate me from my family and so on, and it's just like I don't see it. And I think many people don't see it, so indeed.
So you have an interesting double role with ETH and Microsoft. So what will be your focus on bringing these things to real value in the near future?
So I actually showed a lot of the things we work on with the team. So it's really about this spatial computing, essentially. It's these devices, the value they bring is really what information they can make easily and intuitively available to people. And a lot of that information is the information that actually relates to the space. I mean, in general, if you look at people, there's 2 things they care about. It's interacting with people, and it's learning about the world. And so what we've in particular focused on with my team, there are other teams looking at human communication, avatars and things like this. How could I get a remote person and get the feeling of actually being with that person, discussing, and having that strong communication? That goes beyond just limited kind of view. What my team is really focused on is understanding the environment, building maps of the environment, allowing to really make that spatial data available in a simple way, in a background way, in a way that always works. Currently, if you try HoloLens, with just what's on board, because this device will have a map and can place data, but it's not that easy to share it then with another device. Another HoloLens would actually not know where these holograms of these devices are, and so on. That's too much friction. That means a lot of use cases that everybody can show in a proof of concept, but nobody can actually deploy it. So it's that type of things that we're really building now, the real solution, so that people can build on top of that.
Thank you very much for your thoughts, Marc.
Thank you.
And a lot of success to your team. Finish.